In this problem, we are given a solid shaft that is 5 meters long, or 5,000 millimeters, and it is stressed to 60 megapascals, or 60 newton per millimeter squared, when twisted at an angle of 4 degrees, using a shear modulus of 83 megapascals or newton per millimeter squared. What power the shaft at 30 revolutions per second can transmit? To solve this formula, we utilize the formula for power that's equal to the torque times the angular velocity. However, we are not given the torque, so that is what we need to solve. And to solve for torque, we can utilize the shearing stress formula that is equal to the torque times the radius divided by the polar moment of inertia. We are given a stress of 60 Newton per millimeter squared, and we can try to disregard the unit to make our equation much cleaner, because all dimensions are consistent in newtons and millimeters squared. So we have 60 equal to the torque T times the radius, that is diameter divided by 2, over the polar moment of inertia for a solid circular shaft, that is pi d raised to the 4th power over 32. Cross multiply, we get 60 times pi d raised to the 4th power over 32, and divided by t over 2, that is equal to the torque. Simplifying, we have our torque. This diameter here will cancel. This will become d raised to the 3rd power, and let's use our calculator to simplify these expressions. We have 60 times pi divided by 32 all over 1/2. We have 15 pi over 4 d cubed. And for our second equation, we will utilize the angle of twist formula. That is, the angle of twist is equal to the torque T times the length divided by the polar moment of inertia times the modulus of rigidity, or the shear modulus. We have a angle of twist of 4 degrees, converting into radians, multiplying by conversion factor pi over 180 degrees. This is equal to the torque T, that is equal to 15 pi diameter cubed all over 4 times the length of 5,000 millimeters. Let's disregard unit first. All over the polar moment of inertia, that is pi d raised to the 4th power over 32 times the shear modulus of 83 megapascals. And we can now solve for the diameter. We have 4 times pi over 180 equals to 15 pi d raised to the 3rd power over 4 times 5,000 all over pi d raised to the 4th power divided by 32 times 83. Keep solving, we get our diameter. So we have the diameter equal to 103,546.59 millimeters. And then use this value for D to solve for the torque. We have torque equal to 15 pi over 4 times the diameter cubed. We have the torque equal to 15 pi over 4 times the diameter cubed. That's equal to 1.307942.156 times 10 raised to the 16th power Newton millimeters. Now we can solve for the power by multiplying the torque, that is equal to 1.307942.156 times 10 raised to the 16th power Newton millimeter by the angular velocity of 30 revolutions per second. And let's convert this into radians. We have 2 pi radian per 1 revolution. These 2 units cancel. And also, we also need to convert millimeters into meters to get our unit of Newton meter per second, which is basically watts. So multiplying this by a conversion factor of 1 meter per 1000 millimeters, and these two units cancel. So we have our torque times 30 times pi, 2 pi, times 1 over 1000. We get the power of the shaft that is equal to 2.46 times 10 raised to the power of 15 watts. And that is our final answer.